All right. Now that we've gone over all these equations about the Stargate's accuracy, or the Stargate system's accuracy level, let's go through and let's run through an example. Okay. Okay. So let's say that the distance between A and B, let's call that. Let's just set that at 3,000 miles. So R equals 3,000. Okay, and let's use a nice square, round, even number for n there, and let's say n equals 8. All right. Okay, so I'm not going to bother going through all the work of calculating this because I've already done it. Okay, so what this is basically going to result in is A is going to equal, okay, enable miles. Okay, A is going to be 74.429, blah, blah, blah. So, miles. Okay, so we can, I guess we can, yeah, this. Okay, so roughly it's going to be 74.5 miles, give or take. Now let's kind of try to understand this. What does this number really mean? It is very simple. Okay. Now we have n is going to be 8. That's going to be the number of divisions from the 90-degree corner starting that we're going to have. So we're going to have blah 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 blah. Okay, this circle is going to be turned into a polygon. Okay, and each polygon will have a certain angle to it, and a certain angle, for example, this first one will be at this point, and at this point, at this point. But really, what that means is we can create a connection, a wormhole connection between point A and point B. Each point along here is going to be A. Okay, it's going to be, in this case, it's going to be 74.5 miles. So now, if this is a globe, if this is a spherical object that we're trying to travel through, whatever, that means we can create a wormhole to any place within distance r here, and that's so what's a good way to explain it? Okay, that means every 74.5 miles we can create another one. It's like a grid pattern, really. Let's take a very simple grid pattern right here, just like this. Okay, and the spacing, the size of each grid point is going to be 74.5 miles. Obviously, the higher number of n, and the smaller number of r means the smaller that this can be going to. Okay, so to kind of recap, the higher number of n, the more accurate we can be with our Stargate address, which really means that the more places we can get to. Okay, and obviously, if the longer that r is, the more inaccurate it's going to be, and the shorter, obviously, the inverse of that. Okay, so let's go on. Okay, I think this should be very easy to explain, very easy to understand, actually. So A and R, they're going to be using the same units. If you're talking about centimeters, miles, whatever, it's just the length, whatever units of length that you're using. And that's what A and R are going to be measured in. Okay. Okay, so now we got that out of the way, and let's talk about some considerations first. Okay, there's going to be some considerations, and we kind of touched on this before. Is within a certain amount of accuracy. If both of these points A and point B are moving, we're going to have a very serious safety issue, and we've already talked about that. And I've already mentioned about terrain already, so I don't think we really need to mention it again. But obviously, this is only for static Stargate systems, static wormhole devices between 2 points in space-time. However, if point A and point B are moving at all, then we already have the information how to adapt for this. It's called the dynamic Stargate system. And that's really all you need to know about the accuracy of Stargate systems. Definitely remember this formula right here. It's just an arithmetic sequence formula, and this right here is our Stargate accuracy formula. Okay.